Again, welcome back to the online tutor Simple Harmonic Motion revision session. In this session, I'm going to discuss another sum. Right, so now you can see the sum on the screen. A particle of mass m is attached to one end of the elastic string of natural length a, and the modulus of elasticity ng. The other end of the string is attached to a fixed point O. The particle is released from a rest from the point P, which is at depth a by 2 below O. Show that the particle arrives at the initial point in the time a over g square root 2 plus 3 pi over 2. Find the greatest speed of the particle. Okay. First of all, I'm going to draw the initial position diagram. This is my particle. The length is a by 2. And it's starting from the rest, and after some time come to here, another a by 2, right? So actually it's from the u velocity, here it's v. We can apply u square plus 2a is v 0. It's 2g a by 2 v equal root ag. And also the modulus of velocity is given mg, and we have find the distance, and we can find the time taken, u plus at, g t1 is ag, so these are the time taken, and the velocity of the first the end of the natural length, right? So then after it comes some distance. This is natural length L A, and I assume this is x. The particle is at here, the tension is T, the acceleration is x double dot. So we can apply F equal ma now. Down mg minus T mx double dot. So T means using hook rule, lambda e over L. Lambda is mg, e mean x, natural length is L A. Okay, so now I assume g over a as y, omega squared, x minus a as y, and I'm going to derivate it. X dot equal y dot, x double dot equal y double dot. I derivate it 2 times by the time, so then it's y double dot. This is g over a, y equals 0. Probably this is omega squared, y equals 0. So omega means square root g over a. So therefore particle going simple harmonic motion is going simple harmonic motion. Alright, so by the way, after we need to calculate the amplitude, and we have to find the center and all, right? So these times taken and the velocities are required. So I put it here. V equal ag square root. The time t1, it's a over g. So I'm going to erase this. So then the center, how to find the center? The center mean y equal to 0, no? The y mean our center. So y is the real variable to calculate the distance of the simple harmonic motion the particle, but actually x mean the extension, right, from the natural length here. So y equals 0 mean x minus a equals 0, no? X equal a, right? Then we can draw it a natural length, another a, this is the center, and amplitude. How to find the amplitude? You know, in this particular point the velocity is root ag. So x dot is squared, omega is squared, amplitude minus x squared. So this is root ag. Omega is squared, so we know GA. So this is the point I'm applying. Omega is squared, x mean the distance from the center. This is a squared. G cancel. A minus a squared. A equal 2a squared. A equal root 2a. Amplitude is root 2a. Okay, so then after we have the amplitude root 2a, and we need to calculate the time taken to reach the going down and coming back to the starting position. So actually this is my alpha, this is root 2a. So tan cos alpha one over root 2, cos alpha 1 over root 2 mean at the time alpha is pi over 4. This is pi minus alpha. So then the time taken will be t equal, assume is t2 theta over omega, no? It's pi minus alpha, pi minus pi over 4 over omega. It's 3 pi over 4 omega. Omega mean root g over a, but it's reciprocal a over g. So the total time it's going down and coming up, so down here to here to get the natural length a by 2a to here. The time taken is root a over g plus 3 pi over 4 root a over g, but it's twice because it's going down and coming up. So the final time will be, you can pull root ag out, 1 plus 3 pi over 4. So when you put it to the bracket, it's root a over g 2 plus 3 pi over 2. And also it's they asked to find the speed, the greatest speed of the particle. The greatest speed is always at the origin because the particle is going fast at the origin. So origin mean y is 0, no? So then we can apply our velocity equation, v squared omega squared a squared minus y squared or x squared equation. At the center at the center V squared equal omega mean G over A, amplitude it's root 2a, it's 2a square, this is the maximum speed at origin. At origin.